and it's also used to run native software in a web browser via WebAssembly. What's tricky is that each assembly language only works on a specific CPU architecture, like ARM for Apple Silicon and Raspberry Pi, or x86 for Intel chips. To get started, you'll first need an assembler, like the NetWide assembler for x86 chips. An assembly program is divided into 3 sections. The text section contains the actual logic for the program. By convention, it contains an entry point called start, which is where the code will start executing. Next, we have the block starting symbol section, which contains variables that might change throughout the lifecycle of the app. And finally, the data section is where we can initialize constants, or data that does not change. To declare a constant like a string, we start with a label, then use db operands for the register name and the data to store there. In this case, number 1 is used because it corresponds to system write on Linux. Next, we need to tell the system where to write, in which case we'll move 1 into the RDI register, which corresponds to the standard output in the terminal. The next register stores the message to write along with its length. Now execute the code stored in the CPU by calling the operating system kernel. Almost done, but we'll get a segmentation fault if we try to run it at this point. Update the RAX register with 60 for system exit and provide an error code of 0 for success. Now use the assembler to compile or assemble